Hello, this week we are looking at annuities. Now with annuities, you can tell that it's an annuity versus just regular compound interest because you are making payments. So here we have Alice making payments of $100 every month, and she's earning interest on that, saving up for retirement. How much money is she going to have for this savings? So first thing I always do is I will calculate my I. We divide by 12 because it's monthly. Calculate N, we have 35 years times 12, so 420 months. And then we plug this into our future value formula. We have payments times and when you calculate all this out, you'll get 124,252.52. Now, the Sharp calculator allows you to calculate this in one step using the right view features, the A over B button for the fraction and brackets. If you don't have the Sharp, keep every decimal and you're in between calculation steps. Example 2, Ben has taken out a loan to pay for a car. What payments is he going to need to make if he wants to pay it off in 4 years? So here, we're going to calculate I, which is divided by 12 again because it's monthly. But here you'll notice the payments are every 2 weeks, the end of every 2 weeks. So the payments and the compoundings don't match, so we have to do a correction. So we're going to do 12 over 26, compoundings over payment frequency, and then we calculate I2 by taking 1 plus our I to the power of C minus 1, and this will give us our modified I. Now this is correcting the interest amount for monthly compoundings to coincide with the payments, okay? And then we need to calculate N, which is 4 times 26. This is the number of payments made. Now you can put it into your formula. Now this is present value because you have $8,000 present value of the loan. We're looking for payment. Remember, it's a negative exponent here. And then you're going to calculate that out and do 8,000 divided by what's in that bracket, and you will get a payment of $84.52. Now, because we've rounded the payment, in practical application of this, the rounding of your payment means your last payment for the loan is going to be larger or smaller depending on how you round it. Example 3, we have Cheryl wishing to save up some money. So if she's going to put $800 away, how long is it going to take for her money to amass to $60,000? So again, we can calculate I. And then we use our formula for N. Again, make sure you use the right one. There's one for present value and one for future value. Here we're trying to get $60,000 for future value. We have ln 1 plus and then when we calculate this out, we get N equals 65.72. Now, calculating this out, make sure you use the ln button on your calculator. Ln stands for natural logarithm. And make sure you use your brackets and your fractions, or do it in multiple steps, just keep lots of decimals. Now, N equals 65.72. This is always going to get rounded up. This is 66 months. But that's not how long. Well, okay. Normally we switch it to years. So we're going to take the 66, divided by 12. So we have 5.5 years for our final answer. All right, example 4, we have Dave paying off a loan, but we don't know how much his loan's for. So let's see if we can figure that out. So first, we're going to calculate I. Divided by 52 for weeks in a year. And then our N, we have 2.5 years times 52, so 130 weeks total. We're looking for present value. Calculate this out. And his loan was for $14,989.76. Example 5, we have Ellen paying off a loan. We know her loan amount, we know her payments, we just don't know how long it's going to take her to pay off the loan. Now, we can start with calculating I. But the interest is monthly, yet the payments are quarterly. So we're going to have to adjust. So now the interest coincides with the payments. Now we need to calculate N. Now it's a loan, so it's present value. So we need to use the right formula. N ends up being 14.66. But again, we always round up, so it's 15 quarters. We take the 15, divide by 4, and we get 3.75 years. One more example. This time Fred is trying to save up money, but we don't know how much money he needs to put away each week in order to save this money. So we have I. But we're going to have to adjust it. Figure out N. And then he's trying to save up, so we're using a future value formula, but looking for the payments. Which end up being 172.29.